There's no way around it. You got to know how to find the perimeter in the area of basically all shapes that are 3 or 4 sided on the ACT. Remember, perimeter is just how long a fence would you need if you had the yard, right? If you had a triangular yard, how long a fence would you need to fence it in, right? It's the distance around the outside edge. Area, on the other hand, is how much grass you'd have to cut, right? Now, the ACT doesn't usually let it be quite so simple. They usually combine an algebra skill or some other stuff in with these perimeter area questions. But I do want to spend a little time on it because you will see them on test A, and you'll see them wrapped into really tough questions. Let's look at this first example. We're going to do 2 examples, one perimeter, one area. Triangle below has a perimeter of 17. Okay. So it looks a little like this. Make it tilty. Make it tilty. So this would be 5x and 2x. So this combines make an equation with knowledge of perimeter, because you're going to have to use the fact that they give you a perimeter of 17 to find out what x is, to find what the longest side is. So perimeter is just the sum of all the sides, all the exterior sides. x plus 2x plus 5 is 17. Combine like terms, that'll be 3x. I'm going to go ahead and move my 5 over to plus 5, so I'm going to subtract 5. 3x equals 12. That means x is equal to 4. Now, hold your horses, because if you want to run off and pick C, 4, you're going to miss this problem every time, because they don't ask you what x is. Now, sometimes they will, right? They're asking you what the length of the longest side is. The length of the longest side is not 4, it's 2x, it's 8. So I strongly encourage you to underline or circle that sort of thing whenever you come across a 2-step problem like this, so you don't make that mistake. Remember, if you have the book, you have access to a printable copy of the geometry and trig problems, so you may want to do that. I'd suggest that you do. Okay, let's take a look at the second one here. Triangle ABC has an area of 16. Its base is marked. What is its height? So while we talk about this question, I want to bring up one other thing about finding the area of a shape that has what I call slanted sides. Not a very technical term, but it's an accurate one. Whenever we have any shape that has slanted sides, regardless of whether it's a triangle, a parallelogram, trapezoid, we're always going to use the perpendicular height to find the area. The up and down height. It's got to make a 90-degree angle with the base for us to use that to find the height. And you can see that marked on this triangle here. We have this up and down height, this flagpole height. Never the slanted sides unless you're doing perimeter. Okay, so in this case, it's really a plug-in problem. You got to know a couple things. First off, you need to know the formula for the area of a triangle. Area equals 1/2 base times height. And then you got to plug in the right spot, right? 16 equals 1/2. No, we have the base. It's 4 times height. And somebody asked me this not too long ago. Can you go ahead and multiply these together? Sure, you can combine all the like terms you want whenever you're doing a problem. That's okay. 1/2 times 4 is 2. 2 times height. And so divide by 2. Height will equal 8. I want to talk just for 1 second before you turn this video off about why this formula works the way it does. 1/2 base times height. Recall that a rectangle is length times width, or depending on where you live in the country, or maybe where your teacher is from, or whatever idiosyncrasies apply, you may have learned that the area of a rectangle is base times height, which I kind of like that because it kind of makes sense. It is, right? Length times width. You can also say base times height. Well, if you watch the interior angles video, you remember that a rectangle is 2 triangles, right? So if a triangle is half a rectangle, it makes sense that the area of a triangle would be half the area of a rectangle with those dimensions. That's how that works the way it does. And that's another reason, by the way, because you're using these 90-degree angles with the base and the height why you need that perpendicular, that up and down height. Okay, make sure you check out the rest of the videos in this series on triangles and on right triangles. Triangles are the most commonly tested shape, really, really important stuff.